All right, so you should have done your we do practice, and now we're going to check and see how you process the we do really quick. So going through the steps, it says that we want to make sure that it's fully factored. This is an example of difference of two squares, right? I have two perfect squares being subtracted. So anytime I see that, I should think difference of two squares. So we end up with 4 over x minus 3 times x plus 3. Okay. From there, we're going to determine what are our holes, vertical asymptotes, and horizontal asymptotes. So first, looking at our holes, is there anything that eliminates? No. So there are no holes. Okay. Vertical asymptote. Your vertical asymptote depends on your denominator. And our denominator, we have x minus 3 and x plus 3. So I have x minus 3 equals 0, and we have x plus 3 equals 0. So where are our vertical asymptotes? At -3 and +3. Okay. Next is our horizontal asymptote. Your horizontal asymptotes depends on the degree of your numerator and the degree of your denominator. Okay. The degree of our numerator, I'm going to actually use n so that you guys be happy. The degree of the numerator is actually less than the degree of the denominator. And what happens when the degree of the numerator is less than the degree of the denominator? It's at 0. Your horizontal asymptote is at y equals 0. So those are my discontinuities. So as far as it goes, I'm going to highlight 1, 2, 3. So I have a vertical asymptote at -3, a vertical asymptote at +3, and a horizontal asymptote at 0. Okay, so notice how, yes. Yep. So example 4, if you did it, notice that this time, instead of just having one vertical asymptote, you actually had 2. So what that means is that there are 3 different shapes occurring on this graph. Okay. Next, we're going to find our x-intercepts. Are there going to be any x-intercepts? The answer is no. Why can there not be any x-intercepts? There's an asymptote at 0, right? So there's no x-intercepts. Can there be y-intercept? Yes. How do we find our y-intercept? We plug in 0 for x. So everywhere there's an x, we plug in 0. So we have 4 over 0 squared minus 9, which is just 4 over -9. So our intercept is going to be at 0, -4/9. Ooh, I like how that 4 looks. Yeah, I like it. This one right here. Yeah, turned out decent there. All right, so my y-intercept is right here. How did we get what? So your y-intercept, we said that you're plugging in 0 for x, and 0 minus 9 is -9. So my answer is just 4 over -4/9. That's my y-intercept. That's it. All right, so what happens here, this tells me, we're not going to draw it perfectly to scale. We're going to also look at it in the calculator. But this tells me that my graph is following the asymptotes this way, in the middle. So in the middle, it is following the asymptotes like so. Because I can't cross, so I must be going down, right? I can't have that horizontal, so I can't go up. I must be going down. It sets a boundary for me. Okay? To figure out what's happening on your left branch and your right branch, that's where you create the table to figure out those values. So I'm going to, you also can do it in the calculator. We can do it really quick by hand though. So right here, I'm at -3. To the right of -3 is -4. Here I'm at +3. To the right to the right is going to be +4. If I plug -4 and +4 into my original equation, what's going to happen? So we have 4, and then we have -4 squared minus 9.
Don't we have to correct for what's the word? For 7?
I'm listening.
So when I put it in the calculator, the spot where it has error in the table, would you that like
Those are our asymptotes. Your error can be a whole gap or asymptote. And for our errors, an error on the calculator can be a whole or an asymptote. Any type of discontinuity is going to create an error. You have to be able to calculate. So did we have a hole here? No. So therefore, those errors are our asymptotes. Okay. So, who just talked to me? Z. He said 16 minus 9 was 7. So we had 4 over 7. The same thing's going to happen at 4, right? Because the negative is going to be the same effect. So it's also going to be 4 over 7. So we know that our graph is doing this. It starts somewhere in here, and it's just going to follow the asymptotes. Follow the asymptotes. And it's going to mimic it on the other side. Follow the asymptotes. I followed it too well there. Okay, so we're going to look here and talk about our domain. So your domain here has how many things that it cannot equal? Your domain has 2 things, right? It cannot equal -3, and it cannot equal +3. Do we see that? Your range cannot equal just 0. So on your homework, it wants you to go back to writing your, I think it's going to probably ask you to write it as inequality also. So when I'm writing this as an inequality, this is saying that your x is less than -3, right? Because that's to the left of -3. Does that make sense? Okay. The middle, if I'm in the middle, that's telling me that x is between -3. That's a weird -3 and +3. And if I'm on the right, it's telling me that x is greater than 3. Does that make sense? So reading from inequality, this happens to the left, which is less than a -3. This happens between, do we see? This happens between -3 and +3. And this happens to the right or greater than 3. Okay. And then for your y's happen everywhere but where? At 0. So your y is either going to be greater than 0 or less than 0. Or y is less than 0. But will it ever equal 0? No. Okay. So you got to be comfortable reading what's happening on the graph. And again, it's all based off of left to right, middle, center, and going from there. Okay. If you put this in the calculator, this is what it'll look like. Did anyone actually graph it to see the funness? Yeah. Yeah. The only thing is that you don't see the asymptotes because you put the 4 over x squared minus 9.
So it's just going to have that little like that. So it's not going to have the.
No, it doesn't show you your asymptotes. That's why you have to be able to do it manually.
So you can look for the errors, right?
You just gotta know if the error is an asymptote or a hole.
So it's like can you have 3 errors, so it's like a whole asymptote. You should figure out.
You have to know which one they are.
So you could just look at the table and look at the graph, and if it looks like this.
Yep.
Find out there's no hole.
All asymptotes. Yep. All right. The other one. This is another example of a unique rational when you graph. This one we're going to go straight to the calculator to graph after we find our asymptotes, okay? So on here, this is an example of something you cannot factor. Do we see this? Because we ask ourselves, is there anything that multiplies to give me -2 but adds to give me a +2? And the answer is no, I cannot. This is fully factored, right? Because it's fully factored, when I describe my asymptotes, I know that there are no holes, right? My vertical asymptote depends on my denominator. So where is it at? 1 at x equals 1. And my horizontal asymptote depends on the degrees of my numerator and denominator. The numerator is greater than the denominator. So that means that there is no horizontal asymptote. All right, so let's talk about graphing this bad boy. When you're graphing a rational function, you want to make sure you put the numerator in parentheses and the denominator in its parentheses. So I'm going to put parentheses, x squared plus 2x minus 2 divided by x minus 1. It's weird, isn't it? Okay. So let's look at this bad boy. It's coming in. It's like, oh, tricked you. Oh, there we go. Okay. This is a rational function with what we call a slant asymptote. Okay. It is not part of our curriculum to find the slant asymptote, but this is called a slant asymptote. No. You just have to be able to read the domain and range of what's happening here. Does that make sense? I'm not asking you to find the slant asymptote, but you have to be able to read the domain and the range. Yeah, so I'm going to plot it out for you really quick. We have a vertical asymptote at 1. We know that mathematically, right?
Yes.
Because we already found that. And then when I look at the table to second graph to look at the table, I can plot some points to figure out everything else. So when I'm plotting my points, see at 0, I know that I'm at 2. At -1, I'm at 1.5.
Yeah.
Right? And I don't know, at 2, I'm at 6. 1, 2, 3, 4, 5. I can count. At 3, I'm at 6.5. So I can see where the graph is shaping out. So the graph is doing this. It's following my vertical asymptote, and then it keeps going, right? On this side, it's following the vertical asymptote, and it's going to keep going. But these values are doing what? They're decreasing. They're going down. Okay? And that's because there is a horizontal asymptote that's here. If you are trying to figure out that horizontal asymptote, you just do long division and you'll find that horizontal asymptote. Do y'all remember long division? And you would just do long division or synthetic and you would find it. But again, do we have to worry about that? No. Our goal is we have to be able to write the domain and the range. Okay? So we're going to describe our x's. What are our x values doing? So the only thing x can't equal is what? 1. X can't equal 1. Do we see that? The only restriction for x is x cannot equal 1. Other than that, x is either going to be less than 1 or x is going to be greater than 1. That's the only restriction for our x. Okay, our y's are where it gets a little different. Our y values have a different. So our y's on the left side, they go as high as what? What was this value? 2. So y's are less than 2. Or what happens on the left side? What was this value? 6. Or y is greater than 6. Now, because there are points there, it's not just that they're less than, they are less than or equal to or greater than or equal to, because they have value there. If I have value, I am equal. Does that make sense? Mm-hmm. If I have a discontinuity, I am strictly less than or greater than. Value makes me equal. Okay. The goal for this type of graph is to be able to define your domain and range. not to find the slant, but to be able to define the domain and range. What is your X and Y doing? Got it? What are your questions about reading and finding the domain and range? Done? We're okay? We see where X starts, X ends. We see where Y starts and Y ends.
What is value?
A value means that there's a point here and not an error. So at this Y value, there's a value there, right? This is 2, an X, 2, right? So therefore, that's why it's equal, not strictly less than. Yeah. But on our X's, we can't equal this. So therefore, it's strictly less than or strictly greater than. Okay? All right, that's the goal for graphs like this. On your test, you will have access to a calculator. Okay? At this point, we've practiced being able to graph and specifically identify. At this point, you will be able to graph in the calculator and you have to be comfortable identifying those attributes. Okay? Tell me the x-intercept, tell me the y-intercept, what's happening with your domain and range. Okay. All right, that is it for 3.5C.